everyone, I am Eliza Gilhandayan and today we will be learning about homomorphism. Before we define what is homomorphism, let's have an example first. Suppose that we have two groups. So, we will creatively call this one as the group 1 and the group 2. For the group 1, we assume that it's G sub 1 or we let as G sub 1 and group 2 as G sub 2. So, how we will compare these two groups? That is, how would we determine that those groups are similar or different from each other? And what do we mean by similar? What features of groups are we even using to compare them? To answer these questions and more, we will use the tool called homomorphism. So, if we consider that we have the groups of integers in the left side and the integers mode 2 in the right side. So, here we will both use the operation addition. And the integers are in infinite groups while in the integers mode 2 are infinite groups because it has two elements. So at first you might think that these two groups are completely different from each other. But let's consider that these integers first can be broken into two sets. So we have the even integers and the odd integers. So we say that this even, if we add even and even, so it will result to even. If we add even and odd, it will result to odd integers. If we add odd integers and even integers, it will result to odd integers. And if we'll add two odds integers, it will result to even integers. So we assumed that this even is 0 and this odd is 1. So if we have 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 0. Now let's compare these results to the integers mode 2. So if we have 0 plus 0 is equal to 0 mode 2, 0 plus 1 is equal to 1 mode 2, 1 plus 0 is equal to 1 mode 2, and 1 plus 0 is 1 mode 2. Okay? Did you notice the similarity? If you replace even with 0 and odd with 1, then these say the exact things. This is an interesting observation. By splitting into two sets, even and odd, we see that these two sets behave exactly the same as the group of integers mode 2. We can express this observation in mathematical terms by defining a function f from the integers to the integers mode 2. As you can see here, this is the representation. So, if the integers is even, map it to 0. If an integer is odd, map it to 1. Okay, we have a question here. Is it possible to create reverse function that encodes our observation that evens and odds behave like the group of integers mode 2? So, the answer is no. Suppose we tried to create a function g from the integers mode 2 to the integers. So, we'll send 0 mode 2 to some integer x and 1 mode 2 to some integers y. Since 0 plus 0 is equal to 0 mode 2, we want x plus x equals x. So this because if we are comparing groups, then the behavior of element in the output should be similar to the behavior of the inputs. So solving the equation, we have x plus x equals x gives us x equals 0. So G maps mode 2 to 0. Next, 1 plus 1 equals 0 mode 2. So we want y plus y in the integers equals y. So again, this is because we want the inputs and outputs behave similarly. if we solve y plus y equals y, we get y equals 0. So G also maps 1 mode 2 to 0. So the function G is trivial. It sends everything in the integers mode 2 to 0. So in this direction, we lose the group similarly between the evens and odds and the integers mode 2. So let's keep in mind that in using a function, if in using a function to compare two groups, the direction matters. So in this given function, the integers mode 2 to the integers, it will give us the function g of x is equal to 0 for each element or for each integer x. To know more about homomorphism, let's define what is homomorphism. A homomorphism is if we have two groups g and h under multiplication operation, then a function f g to h is a homomorphism if f of x times y is equal to the f of x times f of y for all x, y in the groups. So in this, we will understand this definition by this example. So if we have here an example, the function integers to itself. So we will use the operation addition. So in here, we let f of x or the function f of x to 2x. So since we let f of x equals 2x, then this defines the function f from the integer z to itself by f of x equals 2x. So to check if it is homomorphism, so in here, in this f of x equals 2x, it will become from the definition itself, using the operation addition, it will become f of x plus y equals f of x plus f of y, just like what we have to our definition here. So since in the definition we use the multiplication of the operation multiplication, but in here in our example we use the addition operation. So to check if it is a homomorphism, we have to know that the f of x plus y equals f of x plus f of y from the definition of the function. So f of x plus y equals 2 times here 2 times x plus y, and on the right side or the right hand side, f of x equals 2x and f of y equals 2y. So we do the math. 2 times x plus 2 times x plus y equals 2x plus 2y. So it has, or they are equal. So here we simply say that this given example is a homomorphism. I hope you learned something about my topic today. Thank you for listening, everyone. God bless us all.